Hi, I'm Kush Jain, a senior software engineer in Microsoft and an ex-Amazonian. I have an experience of 11 years working on highly scalable apps. I'm guessing that you may have also built an app. And before I know anything about that app, I know one thing about it. And that is your application will change. As time grows, there will be new requirements and your application will change. And when it changes, what will happen? This thing depends upon how it was designed. For example, your app may look like this, like a rigid system. Any one small change that you do in the system will cause a cascade of related changes. Or your app may look like this, a fragile system. What happens if we move a wire? We don't know. Boom. Or anything can happen. Or it might be immovable where all the components are closely entangled and it's actually almost impossible to reuse a component without copy pasting from one place to another. Or it might look like this. This is a viscous app where it's easy to do the wrong thing. We know how the designer intended it for us to do, but it's easy for us to shove a new Tupperware directly into the cupboard without caring for what will happen when the cupboard is open. It didn't start out this way. It was perfect in the beginning, but as it changed, new dependencies came in, and these dependencies can kill your app. Design can save you. If your project succeeds, it will continue to have changes and continue to cost you money, and thus the design will pay off. If you haven't done a good design and you have shipped a good amount of features in a short span of time, you can guarantee that you will fail later. Because when they ask you to change, you won't be able to because there was no good design for it. Coming to the solid design principles, I'll briefly touch upon them. S of solid stands for single responsibility principle, where there should be only one reason for a class to change. O stands for open close principle, where a class should be open for extension and but closed for modification. List of substitution principle states that a subclass should be substitutable for its base class. For example, there is a class foo and it has base class fooish. We should be able to replace foo with instances of fooish. Interface segregation principle states that instead of having one generic interface, it's better to have many client-specific interfaces. For dynamically typed programming languages, we need not worry about them, like Ruby. Dependency inversion principle states that we should depend more upon abstractions than concrete classes. Now, all this is very academic. How will it help me make a good design? So, we should think of it like this. Open close is a goal, and this single responsibility, dependency inversion are coding strategies to achieve that. They all here share a common theme, which is how do we manage our dependencies so that we can adapt to new changes with minimal difficulties. Design is all about dependency. If you refer to something in your class, then you depend upon it, and when that thing changes, you must also change. It is these entanglements that can make your code fragile, rigid, viscous, or immobile. How to avoid these entanglements? We should aim to make our app loosely coupled, highly cohesive, easily composable, and context independent. This is just another way of saying the same solid design principles. Loosely coupled is basically achieved through dependency inversion. Your highly cohesive is meaning that this class should talk about the same thing, which is single responsibility principle, and easily composable and context independent are basically how we manage our dependencies. Now let's see an example and understand these principles. So, for example, we are making a patent downloader where we want to get the patent files from a FTP server and download it into a local database. So we can have a patent job which does this for us in this diagram as we can see. We can write a run method in it which downloads the file, pass it and saves it in a database. This is the entire code. Notice in the download file, we are passing the configuration of how to use the FTP, down, net FTP protocol and get the download file. But I have some uneasiness about it. Though it works, but what if the login password changes? What if I need to create another job like this? And what about tests? What if I don't want that there should be a file downloaded with every test? How to achieve this? This uneasiness is good. Basically, it helps us see what the problem is and then fix it. We should have these second thoughts. And another thing is, if testing is seeming hard, then definitely we should re-examine our design. Let's talk about these questions that we need to always have. Whenever we see a very good design in the production, it didn't come out in first place. As new components came in, we again asked us these questions, and after asking these questions, we fixed them, and thus our project evolved into a nice, loosely coupled, highly cohesive, easily composable, and context independent application. So, what are these questions? Is it do not repeat yourself? Yes. Does it have a single responsibility? No. How? So, if you see what the patent job is doing, it is doing two things. It is getting a CSV file and it is storing it in local database. This and indicates a code smell. What if it was an or? It would have been a bigger code smell because then we are talking about the class working with two unrelated tasks. So how can we fix it? We can create a new patent downloader class which will download it and the patent job will parse it and store it in the local. And this will also help our testing. We can mock the objects on the left of the orange bar and we can easily mock our test and we need not download the file with every. So this is the code. How do we use the patent downloader and patent job? The top one is the earlier code and when we create, we can simply create a new dependency. This is a better way to do this. We can inject a dependency into the constructor and it makes our app easily testable. When it's not initialized during runtime, it will create a new instance. When we need it in a test, we can easily inject a mock. But you can have a good argument that the earlier code is shorter. Uh, But you have to think from this perspective that your app will succeed. And when it succeeds, it will have more changes. It can have more tasks to do with the downloaded file. And when it does, then you will need this dependency. So this is how our patent downloader class will look. We just copied, uploaded a file from the earlier patent job over here. Now I can see that there are other things we can do, but the good part about refactoring this design process is that we need not know what the final design would be like, but we can gradually fix one problem at a time. Again, we ask ourselves these questions. Is it dry? Yes. Does it have single responsibility? Yes. Does everything in the class changes at the same rate? No. Why? If you see over here in the patent downloader, we see that the net FTP is not changing. It won't change. But the config that it's referencing will change. With each environment, it can change. So again, we will extract it out and inject. We can make a config reader and the config reader can depend upon a patent.yaml a config file which will have the values for the prod and the test environment and the config reader will accordingly read it and it can be injected into the patent downloader. A patent downloader is pretty generic. We can also call it the FTP downloader. Again, we ask ourselves these questions. Is it dry? Yes. Does it have single responsibility? Yes. Does everything in it change the same rate? Yes. Wow, now it's working. But are we done yet? What about the last question? Does it depend on things that are more stable than it? No. So if you put a files like this, here config and FTP downloader will not change much. as patent job and the patent.yaml file, which contains the individual environmental config that changes with every environment. We should always depend upon things that are on the left. Here's why it's important. If you assign a number to everything on how likely it is to change, then the components with low number are indicating that they are more stable and they are good. A system with low number components is better. It indicates that it is loosely coupled, highly cohesive, easily composable, and context independent. Now, if a low number object depends upon a high number object, then its number is also raised, and then it makes it ugly. So let's look at our code. Over here, the FTP downloader, which is less likely to change, is depending upon patent.yaml, which is more likely to change. How do we fix this? We can move the patent.yaml reference to patent.yaml. And now we are looking at it, we can also see that the FTP downloader actually does not need to have a default constructor. We can simply pass it whatever config it needs and it should be able to download the file. So this is how our code will look like. In the patent job, we can create the config reader object with the patent.yaml file passed to it, and it will pass that to FTP downloader. Here, now, as we can see, the FTP downloader no longer depends upon the config of patent.yaml. So again, we ask ourselves these questions. Is it dry? Yes. Does it have single responsibility? Yes. Does everything in it change at the same rate? Yes. Does it depend upon things that are more stable? Yes. So there are more improvements we can do, but it's a good place we have reached from where we started. I hope you enjoyed this session. Thank you.